Hello everyone. In our last session, we started with properties of inverse trigonometric functions and we had few illustrations to understand them. So in this second session also we have more properties of inverse trigonometric functions. Now the first property what I write here is sine of sine inverse x equal to x. Like in the previous session, here I insist that where does x lie? Now, to make sine inverse x quantity meaningful, obviously, x is expected to be in minus 1 to 1. So, frankly speaking, applying sine from outside and keeping sine inverse inside is much easier than applying sine inverse from outside and keeping sine inside. So, in the previous session, what we had, that is to be understood more carefully. Here, comparatively, things are better. You can write sine of sine inverse x equal to x where x lies in minus 1 to 1. Now, similarly, we can write more properties. Cos of cos inverse x would be x and x lies in the domain of cos inverse. So, it is in minus 1 to 1. Fine. Now, next is tan of tan inverse x and answer is x. Now, where does x lie? In the domain of tan inverse. So, x belongs to R. Next is cosec of cosec inverse x. Answer is x. Where does x lie? In the domain of cosec inverse x. Recall, stretch your mind. What was the domain of cosec inverse? Was it not minus infinity to minus 1? Union 1 to infinity. Correct? Now, what could be next one? Sec? Yes. Sec of sec inverse x equal to x as expected. Where does x lie? In the domain of sec inverse x. What was domain of sec inverse? That is minus infinity to minus 1. Union 1 to infinity. I'm sure that all of you are well prepared and you remember domain and codomain of all inverse trigonometric functions. Mind you, please, unless you remember them, you won't be able to write these properties and hence the applications also. So again and again, I repeat, be careful with domain and codomain of every inverse trigonometric function. So here, it looks very simple, but when you close and suddenly if you are asked something, then you should be in position to answer the correct one only. Okay, so let us move to the next one. And next one, as expected, cot of cot inverse x. Answer is x. Where does x lie? X lies in the domain of cot inverse function and hence x belongs to R. Now with these properties, we try to solve some illustrations. So my first illustration is that we have to evaluate sine of cos inverse 5 by 13. No one gives you sine of sine inverse of 5 by 13. I hope you understand that. Now, we have to be more careful while solving this, as it is not sine of sine inverse of 5 by 13. So what could be your first reaction to the sum? That this is sine of something. And what is that something? Cos inverse of 5 by 13. So, can we name it? I name that cos inverse 5 by 13 as theta. Now, since I am writing cos inverse of 5 by 13, means cos inverse of something as theta. Now, don't you realize that theta has to be in the codomain or range of cos inverse? And what is range of cos inverse? 0 to pi. So, the moment I write cos inverse 5 by 13 as theta, it is your prime duty to write where does theta lie. Theta lies in the range of cos inverse. That is 0 to pi. That is the first thing what comes to your mind. That if anywhere I'm going to name inverse trigonometric quantity, I must write corresponding range part. Fine. Now, how do we proceed from here? That means I am asked to evaluate sine theta because you are naming cos inverse of 5 by 13 as theta. So, our task is to evaluate sine theta. Now, I proceed from here. Now, I recall whatever we have done in our previous session. Can I take cos on both sides of cos inverse 5 by 13? Recall that property. Cos of cos inverse x is x. What we have done just now. X belongs to minus 1, 1. Is this property applicable here? I take cos on both sides provided that 5 by 13 is between minus 1 and 1. And it is. So, I am free to use cos of cos inverse property now. And I do that and I write cos of theta equal to cos of cos inverse 5 by 13, which would be nothing but 5 by 13. Now, 5 by 13 is positive. Try to put more and more constraint on theta. That why do we say only 0 to pi? It could be maybe in a smaller interval also. So try to reduce that interval. I realize that 5 by 13 is positive, right? So since 5 by 13 is positive, that means corresponding cos theta is positive, and hence theta is expected to be in 0 to pi by 2. I hope you understand what I am saying. For theta, we have the only part 0 to pi by 2 and pi by 2 to pi. I mean, we can break that interval 0 to pi as this. In 0 to pi by 2, cos theta is positive, and in pi by 2 to pi, cos theta is negative. Now, the moment I realize that cos theta is positive, I understand that theta is in 0 to pi by 2 and not in pi by 2 to pi. I hope things are clear to you. Now, this would help us in the next steps. I move towards now sine square theta. Why do I do so? Because my aim is to get sine theta. Now, to get sine theta, I will have to use cos theta. So, the best formula is sine square theta equal to 1 minus cos square theta. I substitute value of cos theta, I simplify it, and I get sine square theta as 144 upon 169. Now, tell me one thing, that theta belongs to 0 to pi by 2. Does that not help you in getting sine theta? Sine theta will have to be positive, and sine theta is 12 by 13, and hence the required answer is nothing but 12 by 13. Now, every step is important. I mean, it looks very subtle, but if you pay attention, it has deep meaning. So be careful while solving questions on inverse trigonometric functions, right? Now, we proceed to the next one. And the next one is evaluate cos of tan inverse 8 by 15. Again, the question is not straight as cos of cos inverse something. It is cos of tan inverse of 8 by 15. But don't fumble. I mean, don't get perturbed because of the nature of the problem. We will do it one by one. I am asked to find cos of tan inverse of 8 by 15. What is troubling you? Perhaps tan inverse 8 by 15. So I name it. I write tan inverse 8 by 15 as theta. But then there will have to be some condition on theta. Where does theta lie? Theta lies in range of tan inverse. What is range of tan inverse? That is minus pi by 2 to pi by 2. So immediately I write there, theta belongs to minus pi by 2 to pi by 2. Again, just now we have done one property. Tan of tan inverse, I can write. So I go for, to evaluate cos theta now, I take the property tan of tan inverse x equal to x. Now how do I apply it? Tan inverse of 8 by 15 is theta. I take tan on both sides and I will get tan theta as 8 by 15. Now tan theta is 8 by 15 and 8 by 15 is positive. So what does that tell? That tells that theta would be in 0 to pi by 2. I hope you follow what I am saying. Because in minus pi by 2 to 0, tan theta is negative. Clear? So tan theta equal to 8 by 15 tells more restriction on theta. And theta is now in 0 to pi by 2. Now don't forget that we have to evaluate cos theta. Correct? Information about tan theta is available to me. One way is that you go for the triangle, right triangle thing, what you have done in your previous classes. One way is that. Second way could be that I use this information of tan theta knowing that cos theta is positive. Either I take that triangle thing, or second thing I can use is sec square theta equal to 1 plus tan square theta. Supply that information about tan theta there and evaluate first sec square theta. And that is 289 upon 225 on simplification. Now what would be cos square theta? That would be 225 upon 289. Now when I take cos theta, I will take the positive value of cos theta. Because I have already mentioned that in 0 to pi by 2 theta lies, corresponding cos theta has to be positive, and hence it is nothing but 15 by 17. And what were we looking for? Were we not looking for cos theta only? So the required answer is nothing but 15 by 17. So these were just two examples. We can actually have combination of many such things, because now in one I have taken a sine of cos inverse of something. We never took sine of sine inverse of. Now here I have taken cos of tan inverse of something. So like that we can make various combinations. But the whole idea is that you should be able to apply those properties carefully by remembering that where that theta lies, it has to be in the range of corresponding inverse trigonometric function most of the time. Okay. So when we will be meeting in next session, again I will be bringing something new in inverse trigonometric function. Till then, stay tuned. Thank you.